The knowledge called science is affected by a whole gamut of misconceptions. This is the first of the series on getting science right. We are living the most sci-tech time. No one can be left behind in science, technology, and engineering foundation. Higher secondary science is almost that basics. So, what is science? The French mathematician, theoretical physicist, engineer, and philosopher of science, Henri Poincaré, is the source of one of my favorite insights on science education. He had said, "Science is built up of facts as a house is of stones, but a collection of facts is no more a science than a pile of stones is a house." Science education is like that pile of stones of a house, reduced to laws, curated experiments, classrooms, textbooks, lectures. There is no mental and visual construction of the edifice that is science. As a consequence, technology and engineering future also goes up in the air. Everything we experience or see in our life is science. It is in this context we talk about having a scientific temperament as a way of life. The ability to see the science in everything and be able to explain the action or the lack of it in all things around us. There is little science outside of two basic components. First, observations, experiences, and experiments. It may be added that experiments are to confirm the universalness of observation and experiences, or to closely observe or experience things that are not easily accessible, unsafe, or not precisely quantifiable. Second, logicalization of the observations, experiences, and experimental results into universal truths, what we call as scientific laws. A few examples of how science developed through the ages will help explain the role of observations and experiments in internalizing science. The Italian polymath Galileo Galilei, in the 17th century, asserted that the Earth is not at the center of the universe. This was his way to explain the observation that some planets seem to take a reverse direction in their revolution. He came up with the explanation for this observation that it could happen only if the Earth revolved around the Sun and passed those planets during its orbit. He changed our world forever. In 1971, American astronaut David Scott, standing on the Moon, dropped a hammer and a feather from the same height and found that both reached the surface of the Moon at the same time. The experiment was a dramatic demonstration of the predictions made by Galileo 3 centuries earlier. Indeed, Galileo had set the ground for Isaac Newton by his work on motion of objects in free fall. He had said all objects, regardless of their mass, fall at the same rate in the absence of air resistance. It took that experiment on Moon, where air is led him to refute the ruling theory of the time, Aristotle's theory of heavier objects falling faster than lighter ones. For comparison, Moon's atmosphere is almost a vacuum. The surface pressure on Earth's surface is about 10-13 times more than the surface pressure on the Moon. By the way, this information must trigger thoughts about how this makes entry into the Moon's atmosphere easy, but the touchdown is tricky, and more, such as weather changes, radiations of all kinds. Onto a different trajectory, the discovery of blood is a story. Dr. William Harvey, the founding father of medicine in the 17th century, realized that blood flows continuously through our body when he connected heartbeats to the pulse in the wrists. He was greatly ridiculed for connecting two simple observations through something so big. Yet blood does circulate in our veins, and this was a revolutionary discovery based on simple observations. There is no science education without keen observation, experiences, and open-ended experiments, and significant discussions around the same to filter the underlying truth. Thank you.